Before you decide that light is just another thing that moves, take a breath and imagine this simple challenge. Try to outrun the present moment. No matter how fast you run, how powerful your machine, or how far your imagination stretches, now stays exactly where it is. That strange fact is the doorway into the rule that governs light, time, and everything that follows. When physicists talk about the speed of light, they often start with a number, but the deeper story begins with a pattern. Light does not behave like a thrown ball or a passing car. It does not add your speed to its own. Whether you are standing still, riding a train, or circling the planet in a satellite, light always arrives at the same pace. That stubborn consistency forced a radical idea into science. Space and time themselves must be flexible. Think of space-time as a fabric rather than a stage. You are always moving through it, even when you feel perfectly still. Most of that motion goes into time, carrying you from one moment to the next. But the instant you start moving through space, some of that motion is redirected. The faster you travel across distance, the slower you move through time. This is not metaphor. Clocks on fast airplanes and orbiting satellites really do tick differently from clocks on the ground. Here's where light becomes special. Light does not share your balance between space and time. It uses all of its motion to move through space and none to move through time. From the light's own perspective, if such a perspective can be imagined, there is no journey at all. Emission and arrival happen in the same instant. The universe between them collapses into a single point. This is why the idea of frozen light feels so haunting. It is not that light stops. It is that time, for light, does not pass. And that fact places a hard boundary on everything else. Anything with mass must spend at least a little of its motion moving through time. It cannot give all of it to space. To try would require infinite energy, an impossible demand written into the structure of reality. So the limit you call the speed of light is not a fence placed around the universe. It is the shape of the universe itself. It is the rule that decides how causes become effects, how information can travel, and how the present flows into the future. In the next part, you will see how this same rule, first hinted at by simple measurements and careful thinking, reshaped gravity, motion, and our entire picture of the cosmos for the curious mind. Now that you've stepped through the doorway, the universe starts to feel less like a machine and more like a conversation between space and time. Imagine standing on a platform as a train races past, a beam of light flashing from the front of the engine toward the back. To someone on the train, the light travels a short, straight path. To you on the platform, the same beam traces a longer, slanted route through space. Both of you agree on one thing only. The light arrives at the same speed. That agreement forces everything else to bend. Time in this picture becomes negotiable. The person on the train measures fewer ticks between the flash and the arrival than you do. Their clock runs slower, not because it is broken, but because motion through space steals motion from time. Length joins the negotiation as well. From your viewpoint, the train itself shrinks along the direction of travel, compressed by the same rule that slows its clocks. This sounds like a clever trick, but it carries real consequences. Particles in accelerators live longer when they move faster, not in their own frame, but in ours. GPS satellites must constantly correct their clocks to keep your phone from placing you kilometers away from where you actually stand. The strange mathematics of light quietly guides everyday technology. There is a deeper layer beneath these effects, a hidden bookkeeping system that keeps the universe consistent. Think of every object as carrying a budget of motion. Spend it on moving through space, and you have less left to spend on moving through time. Light spends its entire budget on space, leaving none for time at all. Massive objects must divide their budget, and the closer they try to come to light's way of traveling, the more expensive each extra bit of speed becomes. This is why the universe feels resistant when you push things faster and faster. Energy piles up, mass effectively grows, and the effort required to gain even a little more speed becomes enormous. The limit is not enforced by a wall, it is enforced by a balance sheet written into space-time itself. By seeing motion this way, the cosmos stops being a place where objects simply move around and becomes a network of relationships that must always add up. In the next part, that same rule will turn gravity from an invisible pull into a visible curve, revealing why planets fall, light bends, and the shape of the universe can change under the weight of matter. What begins as a simple beam of light will soon become a map for understanding destiny, distance, and the limits of human imagination itself in motion. Gravity enters the story not as a mysterious force reaching across empty space, but as the natural consequence of that same budget of motion being reshaped by mass and energy. Picture a stretched fabric, smooth and flat, until a heavy sphere is placed at its center. The fabric dips, and any smaller ball rolled nearby begins to spiral inward, not because it is pulled, but because the surface beneath it is no longer straight. In the universe, the fabric is space-time itself. Massive objects carve curves into the paths that everything else must follow. Planets trace loops around stars, not because they feel a tug, but because they are moving straight ahead through a landscape that has been bent. Even light, which refuses to slow down, must still follow the geometry laid out by mass, and so it bends its path around galaxies and black holes. This picture transforms the night sky into a map of invisible shapes. When you look at a distant star, you may not be seeing where it truly is, but where its light was guided by the curves between you and it. Entire galaxies act like cosmic lenses, magnifying and duplicating images of worlds far beyond their own borders. The universe reveals itself by how it distorts what tries to pass through it. Time is not spared from this bending. Clocks near massive objects tick more slowly than clocks far away. A second on the surface of a dense star is not the same as a second in deep space. This difference is small on Earth, but it is measurable, and it must be accounted for in the systems that guide aircraft, ships, and signals across the planet every day. Here, the limit of light speed becomes the thread that stitches geometry and experience together. Because nothing can outrun light, cause and effect remain ordered along the curves of space-time. Events influence one another only within the boundaries drawn by that ultimate pace, creating a cosmic web of connections that defines what can be known and what must remain forever out of reach. In the next part, this web will tighten around the smallest scales imaginable, where the smooth curves of space-time begin to blur, and the rules that govern stars and galaxies collide with the strange behavior of particles and fields. As we descend into that microscopic frontier, certainty fades, probabilities rise, and the universe begins to whisper in the language of chance, showing that the same rule that freezes light and bends stars also governs the fleeting dance of particles that build every thought, every memory, and every moment you believe you are living right now at the edge of what you imagine. At the smallest scales, the universe stops behaving like the smooth, continuous stage you imagined in the last part and begins to flicker like a film made of individual frames. Space is no longer a calm fabric, but a restless sea of possibilities where particles appear, vanish, and reappear in new places without ever traveling the path between them. Feynman's great insight was to treat this chaos not as a problem, but as a story told by every possible route at once. When a particle moves from here to there, it does not choose a single line. It explores all paths, straight and crooked, simple and wildly curved, and each path contributes a tiny whisper to the final result you measure in the lab. Most of those whispers cancel each other out, leaving behind a clear, stable outcome that looks like solid reality. But hidden inside that stability is a storm of virtual events, particles that borrow energy from the vacuum and pay it back before anyone can catch them in the act. The empty space between atoms becomes a crowded marketplace of fleeting exchanges. This is where the limit of light becomes more than a speed. It becomes a rule that shapes how information can flow through this storm. Even in the quantum world, nothing can send a message faster than light. And so the universe protects its own sense of order, no matter how strange the underlying process becomes. When two particles become entangled, their connection seems to leap across distance instantly. Measure one, and the other responds, even if a galaxy lies between them. Yet no usable signal travels in that instant. The speed limit remains unbroken, like a silent referee keeping the game fair, while the players perform impossible tricks. Here, reality feels less like a solid stage, and more like a negotiation. A constant agreement between what could happen and what is allowed to be known. Every observation becomes a handshake between the observer and the observed, collapsing a cloud of potential into a single, undeniable fact. In the final part, all of these threads will pull together, revealing how the universe, from the smallest flicker of a particle to the grand arc of a galaxy, follows one deep, unbreakable principle that ties motion, time, and meaning into a single, breathtaking limit you live inside every second of your life. That limit is not a wall meant to trap you, but a horizon that invites curiosity, daring you to ask better questions, build bolder experiments, and imagine futures where understanding itself becomes the fastest thing you can ever hope to move through, as you keep chasing the light of knowledge beyond shadowed corner of existence. When you step back from the quantum flicker and lift your gaze toward the vastness of the sky, the same invisible rule quietly stretches across distances so large they bend your sense of scale. Every star becomes a timestamp, every galaxy a message sent long before you ever existed, carried by light that has been traveling through expanding space while your world was still taking shape. This means the universe you see is layered in time. Nearby objects show you a recent past, while distant ones reveal eras when the cosmos was younger, hotter, and filled with possibilities that no longer exist. The farther you look, the deeper into history you peer, until at the edge of visibility, you meet the faint glow left behind by the universe's earliest moments. The speed of light turns the sky into an archive. It decides which chapters of cosmic history can ever be read and which remain sealed beyond the horizon. There are regions of reality so far away that their light will never reach you, not because it disappears, but because space itself stretches faster than their messages can cross the growing gap. This creates a boundary that is not a wall, but a moving frontier. As time passes, more of the universe slips beyond what can be observed, not by vanishing, but by falling behind the limits set by space-time's expansion. Entire galaxies drift into permanent silence, existing without any future conversation with the part of the cosmos you call home. Yet within this limit, the universe offers a remarkable gift. By studying the light that does arrive, you can reconstruct the story of everything, from the first atoms forming in a cooling sea of energy to the birth of stars, the rise of galaxies, and the emergence of worlds capable of asking questions about their own origins. Telescopes become time machines. Each lens, each detector, each careful measurement is a way of listening to whispers from the deep past, guided by the same rule that keeps light from ever being outrun. The universe reveals itself not all at once, but in a slow, steady stream shaped by distance, motion, and the constant flow of time. In the final part, this grand cosmic perspective will fold back into something intimate and immediate. You will see how the same limit that governs galaxies and horizons also lives inside your own experience, shaping how you remember, decide, and move forward through a world that is always becoming the next moment, 1 second at a time, under the quiet guidance of a speed nothing can ever surpass. After traveling from the flicker of particles to the slow drift of galaxies, everything finally circles back to you, standing in the present, feeling time move forward 1 heartbeat at a time. The same rule that shapes the path of light across billions of years also shapes the way your thoughts form, your memories settle, and your choices ripple outward into the future. Every moment of awareness is a physical event. Signals move through your brain. Chemicals cross tiny gaps, and electrical patterns rise and fall, all unfolding within the boundaries set by the speed at which information can travel. You are not separate from the universe's limit. You are a living expression of it, a small, temporary pattern riding inside a much larger flow of cause and effect. This is why the past feels fixed and the future feels open. The boundary that prevents any message from moving faster than light also preserves the order of events. Causes come before effects, decisions leave traces, consequences follow. The universe protects this sequence, not through rules written in a book, but through the deep structure of space-time itself. When you imagine changing what has already happened, you are really pushing against that structure, wishing for a signal that could move backward through time. But the same limit that guides stars and particles quietly says no, holding the story of the universe together so that meaning, responsibility, and understanding can exist at all. Seen this way, the speed of light becomes something almost philosophical. It defines the edge of influence, the reach of knowledge, and the horizon of what can ever be shared. Beyond that edge, things may exist, but they remain silent, not because they are gone, but because their messages cannot arrive. And yet within this boundary, there is extraordinary freedom. You can explore patterns that stretch from atoms to galaxies. You can build tools that rely on tiny differences in time to guide ships, send voices across the planet, and map the shape of the cosmos. You can turn curiosity into a bridge between what you know and what you have yet to discover. This is the quiet triumph of understanding. Not that it removes all mystery, but that it reveals where the mystery lives. The speed of light is not a wall meant to trap you inside a small universe. It is a frame that gives the universe shape, a rule that allows stories, histories, and futures to unfold in a way that can be followed and shared. So when you look up at the night sky or down at your own hands, remember that both are part of the same conversation, carried forward by light, guided by time, and bound together by a limit that does not end your journey, but gives it direction, meaning, and a path to keep moving forward.